Hello everyone, and thank you for watching my talk about building a secure cloud application from scratch. The goal of this talk is to cover the basics of the risks that are attached to cloud applications in general and how to manage them by installing some security controls. I will show you how to build a simple CI workflow that will cover the most critical risks so that you will be able to monitor those risks from day one. But first of all, I would like to thank the Israel Clouds organizers for picking my talk and congratulate them for a first awesome virtual summit with a variety of interesting topics and some great speakers. So let's dive in right now with a quick disclaimer. Cybersecurity is a very wide topic, and this talk is only scratching the surface. If you're looking for a deep dive session on threat modeling and cloud security, there are a lot of resources online. Here, I'm basically looking at describing the extended attack surface that your application is exposed to, and to give you some recommendations that you can implement already today. We will build together in a few minutes a CI workflow that should cover the basics. But before that, let's take a look at our agenda for the next 30 minutes. First of all, we'll talk about when it's appropriate to introduce security. And then we'll take a look at the attack surface of a typical cloud application. What controls are necessary to remediate those risks? And finally, we'll build together the security workflow. But first of all, I would like to start by introducing myself a little bit. Besides my PhD in bioinformatics, I'm passionate about technology in general and involved in the security field for a few years already. I'm now the co-founder and CTO at CBrix, a cybersecurity company that is still in stealth. Previously, I worked as a full-stack engineer in the city office of CloudLock and Cisco, where I helped build cloud applications at scale and led some strategic projects. I was also involved in a few communities like PyCon Israel and the AWS Builder Space. So when should you start to care about security? I'm sure that's usually not the first things that comes to mind when you start building a new application. But if you're not baking security in the design of your application, chances are very high that along with your first lines of code, you will already start to gather security debt and that you will always be behind. So when it should be the right moment? The first lines of code when you're starting a new project? The first deployment to production when you're exporting your application to the cloud and to the main risks? Or should it be when you have the first customer? When you start storing some customer data and you need to take care about it? Or finally, is it when you have your first customer request, wondering what you're doing with this data? If I was to ask some engineer what is his main concern while writing his application, he would probably mention functional bugs and performance way before security. And that's also the way startups are picking up their priority. You need to deliver business value in order to survive, accepting the risks in at least until the customer starts asking about it. And that's mainly because security is hard and it's an ongoing concern. It's not something you can deal with once and take a checkbox. It's a journey and a continuous investment. But its cost is definitely lower if you start managing it from the first day. Not necessarily taking actions, but at least be aware of what needs to be done so that you don't spend your time catching up. So I would say in a conclusion that it's never too early to start and to manage your security debt, and you should start right now. If now we're talking about the attack surface of a typical cloud application, what should it be? Well, this is an example. And for simplicity, I took here a serverless application that includes an API gateway that exposes basic REST endpoints, a simple Lambda function that holds the business logic. And here, just for the sake of this example, I also picked an Amazon RDS, or Postgres database that is provided here as a service. The code of this application is stored in a Git repository at GitHub. And the CI/CD system here is GitHub Actions. We're deploying the application to AWS. If you're looking at the map of the risks here, we need to take into account all the places that have an interaction with the application code. It starts on my local laptop, where I write the code in my IDE, and then on GitHub, where the code is stored. Then GitHub Actions, which actually deploys my code and tests it. And finally in AWS, where it runs. Risks are mainly tied to either stealing some secrets, like API keys, or the code itself, tampering with the code by injecting some malicious content, or compromising my AWS account in order to steal some data, or even to leverage some of my cloud resources for Bitcoin mining. So how can I monitor these different risks in all those different places? Well, each area and each risk has a different type of control. It starts with endpoint protection, or in other words, my own laptop. And then we have code scanners that are running in the CI. And it can include both secret detection for hard-coded secrets and static code analysis for some popular vulnerabilities. And there are tools like that you can run and that will help you find some vulnerabilities. You also have software component analysis, or SCA, that will help you find all the vulnerabilities you have in your dependencies that you should also take into account. In the CI/CD, usually you have built-in controls like MFA enforcement and audit that you should monitor for suspicious activity. And finally, for the runtime environment, there are dynamic scanners that can test that my application API security is configured correctly. And you have also some native cloud controls, like, for example, in AWS, you have the Security Hub or AWS Macie that are respectively monitoring for vulnerabilities and sensitive data in S3 bucket. Here, I'm showing a more exhaustive picture of the various insertion points along the software development lifecycle for all the different controls that you can add. For example, here I'm also mentioning the artifact scanners that is relevant for binaries and for containers. So there are a lot of different places where you can add controls, and we will take a deeper look to some of them. So now is the concrete recommendation and the concrete example. For the rest of the talk, I will take a real example. And for that, I picked something that is simple to demonstrate and also very popular. So for the application, I'm using a serverless application that includes an API gateway, a Lambda, and some database. For the programming language, I picked Python, very popular. SCM, we'll use GitHub. And finally, we will work using GitHub Actions, and this is where we'll build the whole workflow. If you want to follow with me, or if you want to see the code afterwards that I'm sharing here, there is here the GitHub repository URL that is public, and you are feel free to either fork the code or clone it on your own laptop. So let's start with the first place that we would like to explore the risks. And this is the GitHub, the place where I'm storing the code. There are a lot of different services that are provided by GitHub. And for all those different services, there are different risks. For example, for the account, you have the risks of account takeover. For GitHub Actions, we have the availability that are tied to these third-party actions. You have different risks here that you need to take into account. And based on what you're using, you should be aware of those risks and adopt best practices. So some of the best practices that you should consider. First of all, enforcing MFA for your organization and branch protection for all your repositories. Reviewing their base permissions as well as any third-party access. And finally, analyzing your audit log for suspicious activity. If you're using your own service like SCM or CI/CD system, then you also need to make sure that you update it regularly in order to use the latest patch. This is an example of a GitHub action that you can run in order to detect users that don't have MFA enabled. Of course, you should enforce MFA at the level of the org, but if you're not doing that, then at least make sure that you don't have any users that you're adding to your organization that don't have MFA. So for that here, we will do the following. We're making sure that this workflow uses Ubuntu latest, and we will use a special action of GitHub that is called GitHub script. That will give us access to the REST API of GitHub by wrapping some node client in that case. And here we're using a GitHub token that will give us access to the members of the organizations. The script here is very simple, and basically we're listing the members of a specific organization, filtering only for users that don't have MFA enabled. And then based on the results, we're looping on the list of the users in order to print the users don't have MFA enabled. And if we have some users, we will exit with 1. That will fail the whole job. We'll see that action at the end of the talk in practice. Another place where you should make sure that you monitor for security risks is your own laptop. If you're building an application, you should certainly have some secrets. Don't store them locally in plain text, either in some .env files or even if in bash profile, because any malware in your system could steal those sensitive data. Use a password manager instead. That will help you both for sharing some sensitive values with the rest of the team and also for injecting dynamically those values into your script. So if you're using 1Password, for example, they have a great CLI tool that you can use. So no need to save the GitHub SSH key, for example, in the file. You can add it dynamically to your SSH agent, and this is an example of how you can run this command to dynamically extract it from your vault and inject it in your SSH agent. And the same thing for the AWS credentials, using another tool called AWS Vault. You don't need to save those credentials in plain text. You can just inject them into your command. Now, obviously, if you should not store your secrets in plain text in your laptop, you should also never commit them into your Git repository. But it may occur inadvertently. Remember here that once committed and pushed, you cannot just simply remove the secret from your Git repository by deleting it, because Git also stores history. So make sure that you use some secret detection tool as part of your pre-commit hook or as part of your CI process. And let me show you how you can easily integrate one of the tools here I'm presenting, one of the open source tools that it has been developed by Yelp called Detect Secrets in order to detect those sensitive values as part of the CI pipeline. Now, a lot of plugins exist to detect all sorts of secret like JWT token or AWS and Azure keys and even basic auth credentials. So this is how the GitHub action is looking. Basically here we're checking out the code and we're setting up the Python environment, and then we're installing the detect secret PyPy package and also some other package called JQ to process the results in JSON. We're running here the commands, exporting the results in a JSON file, and then we're here making sure that we have some secrets that we found, some findings, in order to decide whether or not we should fail the job. And at the end, we're uploading the results as an artifact to GitHub. Now, concerning your code itself, there are lots of types of vulnerabilities that you want to detect as soon as possible. For a list of the most common types of vulnerabilities, I would recommend taking a look at the yearly list compiled by the OWASP organization in the name of OWASP Top 10. Now, a few code scanner exists for Python, and I will show you now how to integrate a very simple one called Bandit. It's a tool written in Python that has a few rules, simple rules, in order to detect some vulnerabilities. So let's see how it goes. This is the GitHub action, and as you can see, it's very similar to the one that we showed a few minutes ago. We're checking out the code, setting up Python, and here we're installing the package from PyPy, Bandit package. We're running it, and we're exporting the results in an HTML file. Here, in this case, Bandit is already exceeding with an exit code of 1 if it finds some vulnerabilities, so we don't need to do some extra step. And as usual, we are uploading the report as an artifact to GitHub. Now, in addition to scanning your code, major risks also lie into your package dependencies. Over the years, multiple incidents have made the news, with the more recent case that was really famous with the SolarWinds use case. Now, specifically here, if we're talking about Python, we have malicious and vulnerable libraries that have been discovered from time to time in PyPy, but it's not specific to Python. Here, I'm also showing another article about NPM and the Node.js ecosystem. So you really need to take care about this, because in any language it can happen. So it's highly recommended to scan your package for known vulnerabilities against a database that is up to date. And let me show you how you can integrate here with the OWASP project dependency check that is supporting multiple languages, including experimental support for Python. So basically here, it's a longer GitHub action, and we'll see how it goes. We're still starting by checking out our code, and here we're setting up also a Go environment, and that's because we want to install this package called pube that will help us parsing the HTML report that the dependency check is generating. We're setting up also Python. That's because we want to create our own virtual environment and install our dependencies from our application. So here we're installing the dependencies that are present in the requirements.txt. And then we have an extra step here where we're caching the database of dependency check. And that's because when we'll run this action over and over, we don't want to download the database every time. So here we're caching it. We're using this special feature of GitHub where we can cache some data between runs. After we do that, we install the dependency check, and we're running the tool with the experimental flag, exporting the results into HTML, and we're suppressing some some false positive actually here that may disturb our results. We're checking the results, and we're parsing it for a specific ID in order to see if we have some findings. And here again, based on whether or not we have some findings, we'll fail the whole job. At the end, as usual, we want to upload the results as an artifact to GitHub. Now, finally, we want to take care about the runtime environment as well. There are a lot of risks that you can only detect at runtime, and that's why it's also important not to only scan for risk in your code, but also in your runtime. And the number of risks really depend on the number of accounts that you use, the regions where you operate, and the service that you use from the cloud. For example, each AWS service has its own list of risks. Regarding specifically your application, you should use some tool called Dynamic Application Security Test. And that is a tool that will dynamically scans the endpoint that your application is exposing. So here I want to explain a little bit the setup of what we want to test. So we have this serverless application where we have an API gateway and a Lambda, and for the matter of the test, we will deploy them using serverless framework into local stack. Local stack is actually uh, um, a project, a great open source project where we'll simulate most of the AWS services. And in this specific case, we want to simulate API gateway and Lambda, so that when we'll use Zap will actually run against API gateway and Lambda inside local stack instead of using the real AWS environment. And that will save us some time and also some money versus doing that against the real application. Now, it's not 100% accurate. It's not exactly 100% the same thing that you will have in AWS, but you can detect already most of the vulnerabilities by doing that. And here I'm only showing that as an example. Of course, it would be also recommended to do that against the real application once it's deployed, but maybe as a nightly build or something like that, nightly test. So how is the GitHub action is looking? So basically here, we're also starting with an Ubuntu latest. Here we have a container, the container of local stack that we use as a service, as a dependency of your action. And here we're basically enabling only the serverless services in local stack, which are API gateway and Lambda primarily. We have a lot of other settings here that I will not explain in detail, except the one here, the option here that we want to have some kind of health check in order to know when the service is up. And that's because we need to make sure that all the services in local stack are up, and especially the API gateway before we run our Zap action in order for it not to fail. Here we have the Zap. First of all, we have here the installation, the checkout of the code, the installation of the node environment. Then we're also installing serverless framework in order to install our application. We're deploying it to a local stack using SLS deploy with the stage local. And we're managing to get the deployment URL, which is changing all the time that we deploy, because one of the parameter is the REST API ID that is random and that is generated by local stack. So we're using this command in order to retrieve that. We're saving that as an environment variable, and this is the input of Zap that we will use. And so that will generate also a report that is automatically uploaded as an artifact to GitHub. And the fail action true is an option that will fail the whole job if there are some vulnerabilities here in our application. So as a summary, what did we build here? Well, basically we built two different security GitHub action workflows. One that we will schedule every hour, and that will take care of making sure that we don't have users without MFA. And the other that will run on every push, and that will take care of detecting secrets, detecting vulnerabilities statically in your code, dynamically in your code, and also checking your dependencies. Now let's take a look at how it looks in GitHub itself. So this is the repositories that I talked about. Here you can find the function itself, the application. Let's take a look at the function. Here we can see the handler. It's a very, very simple application. It basically returns the current time. And here we can see the serverless YAML manifest that will deploy the application, including the part that talks about local stack, because we want to deploy to local stack when you'll use the local stage. And this is the definition of the function itself, which is a very simple function. Now we want to take a look at the workflows themselves. So as I said, there are two different workflows. One that is scheduled, and here you can see the details, and the other that is running on push. And here, for the sake of it, I concatenate everything into one file. Now let's take a look at how it runs. And you can see here in action that it's currently failing, but that's because I want to show you some results. So here, for example, you have the ones that ran on push, and we can take a look at the different actions. Here, for example, let's take a look at the dynamic analysis, and we can see the results here, details about how Zap is running. Now, instead of looking here, we can take a look at the artifacts themselves. So let's go back to the summary, and here we can see the different artifacts. We can also see that basically Zap created automatically an issue with the report and the results of the report. So we can also see that here as text. So you can see how easy it was to build those two workflows. And here I showed only an example on GitHub. Of course, these can be applied to other type of SCM like GitLab and Bitbucket. You just need to change a little bit the syntax. Same thing for the security controls themselves. I basically showed how it worked with an application in Python, but basically you can do that in any language. Now, of course, things are not over yet, and the journey has only begun. But it should already give you some good basics. If you liked what you just saw, then you should know that at CBrix, this is our mission. We want to help engineers own security. We want to automate and abstract security so that it becomes obvious and not time-consuming for engineers to include it when they are starting their new projects. So if you want to join our venture, we're hiring right now. And if you're a security champion, or if you're interested to know more about us, then feel free to drop me a note at david@cbrix.com. We'll also open a beta program soon if you want to join. Thank you again for your attention.